All right, good morning, everybody. It's good to have some time to actually sit and talk to you. Unfortunately, I wasn't able to do anything yesterday. Just, yeah, life stuff. So I appreciate your patience. Hopefully, you enjoyed the video. It's a good example of why classes like this are important because I want you to learn to think scientifically and to not just do everything that anybody tells you and just go along with the flow, okay? Because your physical health, your well being, the well being of the people that you love depends on your ability to think critically about scientific issues like chemicals that are sprayed on food or like the chemicals that are sprayed in your home or just anything along those lines. Okay, so if you ever think, oh, well, why is this important? Okay, hopefully a video like that is helpful in showing you that it is important because these things have real life consequences on health and the well-being of millions of people across the globe. Okay, and it's also impacts you. So without further ado, let's get back to what we've been discussing, and that's been atomic theory. Okay, so if you can recall, we have three uh, substances, three particles, they're called, that reside in an atom. And remember, an atom is the smallest individual unit of matter. Okay, if you want a if you want oxygen, okay, you need to have a certain number of protons, a certain number of electrons, and a certain number of neutrons. Now, protons being the most important part of that, but we'll get to that. Okay, my point is, if you want to have an oxygen atom, you need to have these three things. Okay, or else you just have a proton, or you just have a neutron, or you just have electrons. So it's all of these together that make an atom. Okay, so I want to spend some time looking over some of these concepts. Okay, so first thing is uh, we we talked about protons, neutrons, and electrons, and kind of what they determine. Okay, I said protons determine the element, neutrons determine the isotope, electrons determine charge. Okay, the first thing is, okay, isotope. Don't even worry about that. All you need to know is that they determine the isotope. You don't need to know what an isotope is. If you have questions, you can reach out to me. If you're curious, look it up. It's fairly, I think, easy to understand if you are interested in knowing, but you don't have to. All you have to know is that neutrons determine the isotope. They don't change the element, they don't change the charge. If you were to change the number of protons or the number of neutrons, you would only change the isotope. And we're not going to worry about that. So, really, what I need you to know what changes is the charge, which is determined by electrons, and the protons, which is, or the atomic number or the element, which is determined by the protons. Okay, so if that was confusing, I'm sorry, but you don't need to know anything specific about isotopes other than the fact that if you change the number of neutrons in an atom, you change the isotope, not the not the element itself, not the charge of the element, just the isotope. You don't necessarily need to know what that is. You just need to know that. Okay. All right. So proton determines the element. If you have two protons, you're going to have helium. Every helium atom has two protons. Okay. Protons are also positively charged. So that can be confusing. I say electrons determine charge, but don't protons also determine charge? Yes, they determine charge, but they don't move around. Okay, because if you change the number of protons, what you end up with is a different atom, with a different element. We don't want to change the number of protons when we're dealing with charge. If you want to make an atom more positive, like if you want an oxygen atom and you want to say, hey, I have this oxygen atom, I want to make it positively charged. What you don't do is add a positive proton because you no longer have an oxygen atom. You now have a fluorine, I think, fluorine atom, okay, because that's one more proton than oxygen. What you would say if you wanted a positive oxygen ion is you'd say, I'll take away a negatively charged electron. Okay, so then you're left with an uneven number of protons to electrons. You have more protons than you do electrons. You have 6 protons, 5 electrons, 5 electrons, 6 protons. You have one more proton than you do electrons. That means you have a +1 charge. Does that make sense? Hopefully that makes sense. I'm gonna spend some time. We're gonna work on this. We're gonna hopefully clear some things up. Okay. So what I have here is I have a Bohr model. Okay. You don't necessarily need to know that it's a Bohr model. This is more just that's not how you spell it. Bohr. There we go. This is the Bohr model. Because remember that models are visual representations of things we can't otherwise see. So we can't see a atom. We just model it this way. Okay. So what I have here is a incomplete Bohr model. Okay. But I wanted to show you this because I think it will help you understand what I mean by things like atomic mass, by things like charge. Okay, so we're going to spend some time with Bohr models to help us with this concept. First of all, okay, you can see here, if we look here, okay, this is our nucleus. That collection of things, okay, that's what we call the nucleus. Sorry, it's late. Nucleus. Okay? All the mass of the atom is in the nucleus. Okay? If you were to look at an atom, if you could see it with your eyes, you would see a ball of mass and then the whirling cloud around it. Okay? Because electrons are much, much smaller than the protons, neutrons, and electrons, as you can see, as the protons and neutrons. As you can see here, there's our tiny little electron, but over here we have very large protons and neutrons. Okay? So it makes sense. If we're concerned about the mass of an atom, we're really only concerned about what's in the nucleus. Okay? And the things that are in the nucleus are the protons and the neutrons. Okay? So these two particles are going to determine your atomic mass. Okay? Now, the atomic number is determined by the proton. Okay? So, remember, atomic number, the element, same thing. Okay? Just like every item at the grocery store has a barcode with a number on it, right? Every item has a number. Every element has a number. That number is equal to the number of protons. So a hydrogen atom has one proton. A helium atom has two protons. So what element is this if it has if it has three protons? Okay, go ahead, count those. You can see that there are only three protons in there, right? We have three dark ones, four light ones. Okay, I'm sorry that I probably could have done even lighter colors than that. More contrast, but we have three. Okay, we have 1, 2, 3 protons, right? And we have, that leaves us 4 neutrons. Okay, this would be a lithium atom. Okay, Li is the symbol for lithium. Okay, lithium has 3 protons. Okay, it has 4 neutrons. So if we want the atomic mass, all we have to do is add these, and that gives us 7. So the atomic number, the atomic mass is 7. Okay? Because that's where all the mass is. The mass is in the nucleus. The particles that are in the nucleus and that have mass are the protons and neutrons. So if we're concerned about the atomic mass, we just count up the number of particles in the nucleus. Okay? So the protons determine the atomic number. The protons plus the neutrons determine the atomic mass. Okay? Again, neutrons determine the isotope, but you don't have to worry about that right now. Okay? You don't need to concern yourself with those things. Okay, so let's talk charge. I'm trying to erase nucleus here. There we go. Okay. I'm going to erase that because that's not where I want it. So, charge is determined by electron. Even though protons are positively charged, okay, they have a positive charge. They also help determine charge. They don't move around. The electrons move around. Okay, they move around in these orbits. They fly from one atom to another. They're zinging around all over the place. Electrons are what do chemistry. Okay, nucleuses they don't change. They stay the same. If a nucleus breaks apart or fuses together, those are nuclear reactions, okay? And that's what atomic bombs use. That's what nuclear reactors use, okay? They're big, energetic things. These don't happen just regularly every day. They require a lot of special conditions, okay? But the regular chemistry that we're used to every day is done by movement of electrons, which is why I say electrons are what determine charge, because they're the things that move around, okay? So a neutral atom is going to have the same number of positive charge to negative charge. So if we have 3 protons here, 3 positive charges, in order to have a neutral atom, we're going to have 3 negative charges. Okay? So we're going to have 1 electron there, 1 electron there, and then 1 electron there. Okay? You might say, Mr. Derry, why did you put it that way? Okay. Electron shells have a special number. Okay. It's only a certain number of electrons fit in each shell. Okay. In the first shell, 2 electrons fit. We'll say 2e. In the next shell, you can have 6 electrons. Okay. And then in the next shell, you can have 6 electrons too. Okay, this is just how the energy levels work. If you look at a periodic table, okay, you'll see hydrogen over here, helium over here, right? They're just on their own row. That's the first orbital. You get down, count how many more elements you have. You should have 6, okay? That's because those are the orbitals. Okay, you have one more electron, one more, one more proton, one more proton, one more proton. With every proton, if we want a equal charge, we also have to have a new electron every time. And as we add an electron, those shells are going to fill up. So the first shell is 2 electrons, hydrogen and helium. Okay, those are the ones that only use that shell. After that shell fills up, we go on to the next shell. Okay, and 6 can fit in there. Then the next shell, 6 after that. Then after that, 18. Then after that, 18. Then after that, 24. Okay, we're not going to worry about that. We're just going to deal with the first 2 and maybe the third row of the periodic table. Okay, so this is a normally charged neutral lithium Bohr model. Okay, because we have 3 protons and 3 electrons. Right? Now, if I were to add 2 more electrons here, what would the charge be? Well, we have 3 protons. We have 1, 2, 3, 4, 5 electrons. Okay. So what we can basically do is we can say, all right, 5, 3. We have 2 more electrons than we do protons. Electrons are negative. Therefore, we have a lithium 2 minus. Okay. What if we change, not rather than increasing the number of electrons in the atom, what if we decrease it? What if we say there's not 3 electrons on this, there's only 2. Okay, we still have 3 protons, but this time we only have 2 electrons, which means we have 1 more proton than we have electrons, which leaves us with a +1 charge, or Li plus. We don't put the +1, we just leave plus because everybody, unless it has a number greater than 2, greater than 1, it's 1. Okay, this is kind of what you're going to do. And we're going to do a hard example so that you can look at it. This is your assignment for today. Okay, I have orbitals here. What I don't need you to do is fill up the nucleus. Okay, you don't need to fill that up. What I do need you to do is I need you to draw in actual electrons on these orbitals, on these Bohr models. Okay, so this is a lithium. The symbol here designates as a lithium. If it has a plus like this, that means it's an ion. It doesn't have a plus. This means this is just a neutral. So we're just going to add 2 electrons in the first shell. Okay, remember only 2 in the first shell because they don't fit more than 2 in the first shell. The third one then is going to fill up in the second shell. So this is what your answer, okay, you can make them bigger if you want. Sorry. Put that one back. Okay. How many protons are there in a lithium atom? Okay, that's what we put here. How many go there? Well, the atomic number for lithium and the example that I used was still lithium. I like using lithium as an example because it's a simple one. There's 3 protons. What's the mass of this lithium atom? Well, we know it's the number of protons plus the number of neutrons, which gives us a mass of 7. Okay. So now over here, I say, how many electrons do we have? Well, 3. We already figured that out. Okay. This is what you're doing. You're filling out this table. Okay. You're going to use your periodic table and you're going to say, what's the atomic number of this? The atomic number is just going to go here. Okay. That's why in all of these that give you answers, I don't, the number of protons is completely blank because I don't, like that's such an easy number to find. It's just the atomic number. It's just the big number above the element on the periodic table. That's what goes in the P box. That's the number of protons. It determines the element. It's the atomic number. Same thing. Okay? Now this one is a bit different. Okay? What we have to do is we have to say, okay, there's 4 protons, or sorry, not 4, 3 protons in a lithium atom. And even though it's an L plus, these numbers are still going to be the same because these numbers don't determine charge. The number of electrons determine charge. Okay? So if this is 7, okay, and this is 3, and we know that 3 plus neutrons is equal to 7, what's neutrons? Well, for one, we already talked about it. That's this right here. It's 4. Okay? But we can also solve for it as, subtract 3 from both sides and get n equals 7 minus 3. Okay? 7 minus 3 gives us 4. Right? As you go on, these numbers disappear because I want you to be able to understand a little bit more as to how to actually find this. Okay? You should be able to do it after several examples. Okay? All right. Electrons determine charge, right? Let's do one of the big ones. Everybody turn to the back page. We're going to do the very last one. Okay? Move this here. Actually, let's not fill that up yet. Let's start with this. Okay, this is the number of electrons. Number of electrons. So, if we look at our periodic table, okay, and I'll pull one up here. I like the website ptable.com because it's easy to find. I just put that in the, and it gives me pretty much everything I need. But you can also just use any old periodic table. The one that you use will be just fine. So, what does the periodic table say about this element? Oh, that's not right. Hold on. Please hold. Whatever. Just look at yours. You have yours in the room. I have mine. We just won't be able to look at it together. Ge. Ge is the element germanium. Okay, it's 32. It's under silicon. It's above tin. It's in the third row and the 14th column, or the fourth row, 13th column if you count the two at the top. Okay, 32. So how many protons are there? Okay, if the atomic number here is 32, remember that's just the number of protons. So we have 32. I'm going to look at the mass on here. The mass for germanium says 72.630. We're just going to round up to 73. Okay, because we can't have an uneven amount of these protons and neutrons. Okay, don't worry about why that is. Okay, it's a complicated thing. Just round to the nearest whole number. All right, so that means the mass is 73. If mass is 73, we know that the protons plus the neutrons is equal to 73, right? Okay, number of protons is equal to 32. So if we do 73 minus 32, that's going to give us the number of neutrons. 73 minus 32 is 41. Yes, I did use a calculator. You can use a calculator. 41 neutrons. Okay. All right, so we have this filled out. How do we find the number of electrons? Well, we know that this is a ion. Okay? It's 2 minus. When you see 2 minus, you need to think automatically 2 extra electrons. Okay, I know it's kind of strange because minus we think less. Okay, but in this case, minus means more electrons. Okay, plus means fewer electrons. So 2 minus means 2 more electrons than there are protons. So if there's 32 protons, okay? We need to add 2 more electrons to give us 34 electrons. Again, plus 2, minus 2 seems kind of backwards, but it's not. Okay, that's just how it works because electrons are negatively charged. If you have 2 extra electrons, you're going to have a minus 2 charge. The minus is a convention. Okay, we could say a 2A charge or a 2A and a 2, positive be A and negative be B, and just have A charge and B charge. Okay, we could have square charge and circle charge, right? That's just not the convention that scientists use. The what we use is positive and negative. Okay, so don't think of it in terms of numbers so much as it is just a convention. Okay, so if we have 34 electrons, we need to fill that up in this shell. Okay, the first shell is going to have 2 electrons. I'm going to make this bigger so it's easier for me. Okay, the next shell is going to have 6 electrons. 1, 2, 3, 4, 5. Well, actually, I think it has 8. 5, 6, 7, 8. Yes, it has 8. Sorry, I did that wrong. It's late. These electrons, so if I go back, okay, if I go back here, these are not 6. These are 8. Sorry, it took me so long to actually catch that error. But it is an error. I make mistakes too. So change that in your notes. Each of these shells have 8. Okay, back to this example. Okay, so that gives us 10 electrons total. So now we need to put 8 more up here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 10 plus 8, that gives us 18. We need 32. So that means we need more than that. Remember, now this shell can actually contain 16 total. Okay, because if we look at the periodic table, in the fourth row, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I guess I need to learn my stuff. 18. Good thing I checked. 18. We can fit up 18 electrons in this outer shell. Okay. We're not going to fill up all 18 because we only have 8 electrons left. Because we filled up 10, then we filled up 2, then 8 gives us 10. 8 plus 8, or 10 plus 8 equals 18. Now we need 18 plus 32 minus 18 gives us 14. So we need to fit 14 electrons in this outermost shell. Okay, so we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, again, there's a lot of electrons in that shell. So 14. Okay, now if you count all these numbers, okay, if you count them all, you will be peachy. Okay, we have 1, we have 2, we have 3, 4, 5, 6, 7, 8, 9, 10. Count with me. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, are we done? No, because this is a 2 minus, which means we have 2 extra electrons. So we have to add 2 more. If you caught on to that earlier, good for you. So let's add 2 more. That gives us a total of 34 electrons. 33, 34. Okay, I know that's a complex, complicated example, but that's why I do these tough examples together, because if you can somewhat understand these, you can understand the easy ones. Okay, all right. Last thing, okay, you can watch this video over again. Okay, I have it in Canvas. You have access to it. Get to the parts that you watch the parts that you were confused with again. This paper is long. Okay, some of you might be able to do it all. That's great. That's wonderful. That's why I make it more difficult at the end, because if you're doing it really easily, then you can do those hard problems, and if you can do those hard problems, and then nothing can stop you. You got this completely. Some of you might only finish the first page in this hour, and that is okay. What I want you to know is that in Mr. Derry's room, a lot of times when you get worksheets like this, I have a large swath that slowly get more difficult as they go on. If you can get all the way to the end, okay, that's actually really impressive. Usually the questions and stuff at the end are actually quite complicated. But the goal is to get you through probably maybe the middle. So the first 2 pages you're probably doing pretty good. Ideally the last 3. If you can do the last 4, if you can do all 4, great. Okay, so just do what you can. What I don't want you to do, as like I said before, I never want you to lose sleep. I never want you to stress out about Mr. Derry's class. Okay, because I want you to understand we're going to take the time that we need to do it. I want you to not freak out. This isn't about a grade. This is about learning. Okay, so do what you can on this assignment. Do your best. Work together. Okay, if somebody across the room knows it really well, ask them about it. Okay, if you're somebody that knows it really well and you finish this up, find somebody to help with it. Okay, work together to learn this stuff. Okay, especially since I'm not there. All right, hopefully this was helpful. We will have another quiz about this stuff. And again, I don't want you to stress out about the quiz. I never want you to lose sleep or stress out about my class. So don't stress out about the quiz. I'm not there. I can't see how you guys are doing on this. So my way of understanding how you guys are doing on this is those quizzes. Okay, so it's going to be basically the same quiz that we did last time. Hopefully, a different type of dealing with this information, seeing the more visual things was helpful. I know this was a lot, but I know you can do it. Okay, you can just re-listen to the stuff that you are that you liked and that you need to know. Um, and if you need more help with the example, you can listen to the spot that's just me going over the example. Okay, I'll quit yapping. I'll let you get to work. Thank you for your patience with me. It is fairly late and I'm kind of tired. So have a great rest of your day. I will see you all next time.